Hi, everyone. Good morning. My name's Toby Mills. I'm the founder and CEO at Entopy. This morning I'm going to present on the work that we're doing with Glasgow Airport, which focuses on passenger movement. So for those of you that don't know who Entopy are, which to be honest, I would imagine is probably pretty much everyone, we're a digital twin company. We're based in Cambridge in the UK, and we deliver decision intelligence to operators and strategic decision makers across critical infrastructure. We use the term AI-enabled digital twin very purposefully because alongside data from real-time source systems and historical data, we have this concept referred to as micro models, which is where multiple, very small, very focused AI micro models are deployed across an environment or an operation, predicting very specific aspects of that environment or operation. And the outputs of those are fed into the digital twin and orchestrated together with the real-time and historical data to deliver decision intelligence through prediction and simulation. Now, moving to airports and aviation, I think that this is a very, very interesting area for digital twin and for the digital twin community. The overarching challenge is increasing passenger numbers. The Department for Transport's analysis, some of this analysis is dated, but there's no new that I could find. But there's expected or anticipated to be a doubling of passenger volumes between 2020 and 2040, per the DFT's own analysis, and this is mirrored by the analysis from the IATA. Which sees almost a doubling of global passenger movement based on the constant policies scenario. So this creates challenges in the aviation sector, particularly for airports. You're going to have one side of it, which we're going to see more and more, I think, around more runways and more capacity for flights. But there's the other side of this, which is how are passengers going to travel to the airport? What are they going to do when they get there? If they're driving, where are they going to park? How are they going to move through the terminal, and so on and so forth. And we were very lucky to partner with Glasgow Airport through a Connected Places Catapult competition to look very specifically at this problem. Now, Glasgow Airport, their own analysis suggests an increase of around 6 million passengers per annum between 2020 and 2040. And what's also really interesting is this increase for short stay and long stay car parking demand. And that's because the majority of passengers that that use Glasgow Airport travel there by car, 50% by private car and 20% by taxi. So the challenges are very much on the traffic management and car parking capacity side, as well as moving people through the terminal parts of the airport more quickly. There is also an opportunity for airports in that if passengers can get airside more quickly, they will spend more in retail. So the sort of sum, the rule of thumb is 6 pence per passenger per minute. So there is an upside to this as well as just managing constraints. So when looking at this, we sort of mapped the workflow, the operation, taking a very much bottom-up approach, which is part of the micro models methodology. So starting with the road network, how are cars going to get to the airport and in what volume? Then through to car park utilization, and then moving through into the terminal. So how many passengers are going to check in a bag, and how many passengers? All passengers are obviously going to go through security. So how many at what time and how and for how long before going through to airside. So we looked at this distinct workflow, deployed micro models across it, which then feed into a digital twin with other data sources, and we present that through dashboards, which I'm about to show you. Now, please note that this is a couple of months old. We're early on, but kind of one of the big themes I want to get across is the kind of life cycle, the journey that we're seeing with these kind of infrastructure digital twins. So if I just show you a couple of dashboards, so this is the kind of main operational dashboard. It's designed to be used operationally. There's a nice slider that allows you to move into the respective hour. Along the top, you can see cars predicted into each car park. Beneath that, how many passengers are going to check in and how many passengers are going to go through security, again in hour blocks. These are predictions that are being driven by the network of micro models that integrate into the digital twin. We then have this modal, which is a bit more visual, which allows you to see the various zones of the airport, and we RAG them. Now we're working closely with the guys at Glasgow Airport now to make this as impactful and powerful as possible. At the moment, we're sort of using the historical trends analysis to RAG these things, but this will act as a way of them sort of forecasting the future, but also simulating certain scenarios. So if we were to close this car park, or if we were to open another car park over here, what would it do? And then this analysis is sort of top down. So this model here looks at the flights. What's the capacity of each flight? How many people do we expect to be on it? How many of those people do we expect to check a bag in? What's the processing time? How, when are they going through security and for how long? And as I said, this is all being run by a network of micro models. The model I'm showing you here is a traffic flow model, which is quite familiar. If you've seen any of my presentations before, we've got quite a few of these deployed for ferry ports, but these feed traffic from the road network into the entrance of the port, and then we can start to understand using another network of micro models which car parks are going to be utilized and when. And then you've got those models flowing right the way through that workflow through check-in and security. One thing I did want to sort of cite, I know I've got to whiz through this stuff, but we have used the synthetic data aspect again. I think the last time I presented on the Gemini Call, I was talking about this with another use case. We had a very similar problem in the sense that one of the data sets that we wanted to use to develop a intended micro model was too small. So we've expanded that with synthetic data using generative adversarial networks. And this has been effective again in delivering data that has a positive impact on training of AI models. This research is going to be published. So this is in conjunction with the University of Essex, and we will be publishing this hopefully in the next couple of months. And then just to sort of close, I just wanted to draw on this because we've done a few deployments now, and I always try to sort of think what's kind of worth talking about to the community. This digital twin maturity curve. So we have seen this every single time we've deployed this kind of curve of maturity through stakeholder engagement, user engagement, and operationalization. We talk about it as newborn, infant, teenager, and adult. It really doesn't matter what sort of adjectives you use, I suppose. And you can see where we think Glasgow are a few months in. But we're doing a lot of work to try and accelerate the impact of digital twin earlier on in that maturity curve. So me and the team at Entopy, we kind of see AI agents as being a big part of that. And we've been working on this for a few months now. We have an agent that can talk to the digital twin, documentation and guidance, real-time API, real-time web search, and deep analysis. You can see kind of a test fig next to the to the sort of right of the screen, which is just an internal monologue of one of the tests that we were doing, just to sort of give you an idea of what this is going to do. But we think that this deployed early on in that adoption curve, in that maturity curve, will mean that digital twin can provide more impact more early on in the sort of journey. So I just wanted to sort of share that as well. And finally, just a couple of announcements, if I'm allowed to make them. We have a webinar together with the Digital Twin Hub tomorrow, and that QR code on the screen will take you through to the registration page. It's with Harwich Haven and Pinsent Mason, as well as the Digital Twin Hub, and we're going to be talking about data sharing across complex ecosystems. And then the final announcement is that we're going to be at Big Data and AI World again this year on the 12th and 13th of March. In the Excel, we are going to be demoing, I believe, the agent and various other bits and pieces. So if you want to see that and talk to us, hop along. But I'll close there. Thank you very much.
So Toby, great presentation. Have the team at Glasgow been able to use any of the insights that you've created so far?
At this stage, no, it's early. So it's just in the process of being deployed operationally. So if you like, the twin's been stood up, it's been mobilized. It's now in what we call a controlled release, which is where it's gone over to the data teams to essentially attack those numbers and validate them. And then it will go to the operational teams for them to use. So the insights haven't been used in the way I think the question's sort of asking, but that's an honest statement as to where that project is right now.
Toby, does your digital twin model progress of passengers? Does your twin model progress the passengers through the terminals bottlenecks and security could do with digital twinning.
Yeah, that's exactly the point. So yes, so essentially we're following the customer journey from the road all the way through to airside. So understanding where how many passengers are checking in, how many passengers are going through security, and then the other side of that is what capacity the airport has for processing at that given time. So trying to identify these bottlenecks, which are driven by peaks in demand, which can be driven by particularly busy times, but also arrival rates, you know, all sorts of stuff. But that's exactly what we're looking to model here.
How do you explain the use of synthetic data in digital twins?
Yeah. So I agree with most of that. I think from our point of view, it's also important on the sort of front end of this. So we're seeing very regularly in terms of our perspective, going in, wanting to deploy a digital twin, and the data that you need or the data that's required to develop, in our case, the micro models, not necessarily being available. So this might be the data set's quite small and there's a seasonal component to what we're trying to predict. And so we actually need to extend that data set. There may just not be enough variability in the data that we've got because it's just simply too small. So this is, you know, as I sort of cited in the presentation, this is one of the big things that we've had to do on multiple deployments now, which is where we take a relatively small data set and expand that with synthetic data to give us a data set that we can train the intended micro model with. Yeah, we see it on the front end as well as the back end of digital twin. Very important.